Projectile motion. It's what we're going to do is we're just going to go over some key information about projectile motion, and then I'm going to show you pictures of the 4 general situations that you can get for projectile motion, and then we're just going to draw things on those general pictures, and then we'll go do some examples after. So basically, my first point, the very first thing you should know about projectile motion is that it's basically kinematics in 2D. You're used to doing kinematics in 1 dimension, so you're used to Vf equals Vi plus At, Vf squared equals Vi squared plus 2Ad, d equals 1/2 Vi plus Vft, and d equals Vit plus 1/2 At squared. Okay, those all work still. The thing is that now, when we're doing one of these things, if we're talking about the x direction, you put a little x on all these things, except acceleration, because you're only accelerating due to gravity, so this is always going to be g, but you'll have Vfx, Vfy, Vix, Viy, dx, dy. You'll have 2 different directions, okay? So kinematics in 2D, that's your first little point. The x and y direction are linked by time. That means that once you find a time, you can find time in x, you can find time in y, it doesn't matter. This time frame, your time t, is linked between the 2. So you just need to find it in one place. That's the nice part, because once you find your time, you can use it as the same t value in all these equations for the x or the y. Third point, basically, let's see here, maximum range, meaning how far you're actually able to get something to go. Maximum range is at 45 degrees. So you launch an object at 45 degrees, you'll get its maximum range, you'll also get its maximum height, you'll get its maximum time in the air. Maximum everything occurs at 45 degrees. So that's on a situation like this, okay? You send this angle off at 45 degrees, this will be your maximum height. Your time to the top to here, that time is going to be the same as this time. So all you have to do is find the time to get to the maximum height. You'll times that time by 2, and that can be our next point. Time up is equal to time down. That's for this specific type of projectile motion. Maximum range is 45 degrees, time up equals times down. Okay, and let's look at the 4 types. 4 types of problems. And there'll be some things that are the same for the 4 types of problems, and there'll be some things that are going to be slightly different. Let's look at the first picture. Let's get rid of this, and go to this. Okay, this is your very first type. Okay, this is when you're shot horizontally off of a cliff or something like that. Okay, and basically no angle. That means like you would have a cannon here, and the cannon would shoot perfectly off horizontally. Okay, so some information about this. This is like stop time animation. So here's the object, there it is at a time later, and it falls down. I've got an arrow drawn here. This is your Vx. Vx is constant. That means that at every single point in time, your velocity in the x direction is exactly the same. So if I've done it right, my Vx vector is always the exact same length. So if you're told that this thing is kicked off at the top of this cliff with a velocity of 45 meters per second, it's 45, 45, 45, 45. Okay? Never changes. That's all in your x direction. Gravity, though, and I'm lazy, so I'm going to call it minus 10 meters per second squared. Gravity is going to affect this thing, which is why it gets pulled down. So gravity is pulling down at the same rate. So when you start here, your first initial velocity in the y direction, Viy, is 0. Okay, you start there. As soon as it leaves, there's no initial velocity downward. Then you get here, and you got just a little bit more. VIY increases a bit more, increases a bit more, and at this point it's at its maximum velocity in the y direction, and I won't bother writing it down every time. So VY changes. Okay, and this actually isn't VIY here. This is just plain old VY. This is the only initial y. This one down here would be V final in the y direction. And then there's a whole bunch of y's increasing on the way down. From here to here is the height, but usually you'll hear it in terms of height, but really what they mean, that's dy. And from here to here, this is called the range, but really what that is dx. That is horizontally off a cliff with no angle. And pretty well everything is going to be, is going to have some similarity. So let's look at the next picture. That's this kind right here. This one is launched at an angle. So launched at an angle. Okay, first thing, you can see it here, I'll make it bigger. That theta value there is going to end up being the same as this theta value here, okay? Your ground horizontally across, if you go up in this type of projectile motion launched at an angle, your theta up is theta down. And remember we said your maximum, in this picture, your maximum range, your maximum dx, or your maximum range, is when this is at 45. That's 45, this is 45. From, well, let's look. This vector right here, this is, usually we just say it's a v, and then you say at whatever the theta value. So for instance, 45 meters per second at 28 degrees. Okay, that's how you would call that. That's the velocity that shot up at this angle. From here, you can get two things. You can get your velocity in your x direction. That is going to be, well, we'll use 45 at 28 degrees. That would be 45, x is cosine 28 degrees, and your Vy would be 45 sine 28 degrees. Remember, Vx is constant all the time. So that means that whatever we get for a value of Vx, okay, it's going to be the same all the time. Same as right here. That's always Vx, and Vy changes. So you're going to have this value here is actually your instant, or your VIY. So this is the maximum VIY that you're going to get. And then as it goes up, it decreases a little bit until you get right here, in which case your Vy is 0. When your velocity is 0, from here, this is the maximum height. The time frame to get from here to here, time up equals time down. I'm kind of running out of room, so we'll do it over here. Time up equals time down. There. dx, this is your maximum height or your maximum dy. Vx, Vy, Vx is the same, Vi changes. Your Vi up ends up being the same value but in opposite direction as your V final y. And then there's symmetry. So whatever your velocity is at this exact height, it'll be the same as at that height. Whatever time it takes to get here, it'll be, you could figure out what the time is there. This whole thing is symmetric, which is very nice. That, as well as this previous one, these are the two main types of questions. This one, this one. There are variations. Here's our first variation. This one, we say lands below the origin. Okay? Or maybe not the origin, the original line. So here's your original line. You're landing this height below. So actually, you're just landing a dy value below. And when you do this right, this dy value should end up being a negative. So if your answer ends up being negative 50, that means that you're landing 50 meters below. Everything else about the previous question right here, all of these things, they apply to this. This angle here would be the same as this one, but it has nothing to do with this one. Okay, this one here is not related to this angle at all. So if this is 28, this is not 28. And if this is 28, this is 28, but who cares? That's going to do us no good at all. Your range is still the same thing. It's from here to here. That's your dx. This is still your maximum height. You're going to find your time. How you do that is you will remember that all your x's are the same value. Okay, so you'll use your time. You know that this thing is VIY. It has to be 0 still. You'll know that you can find your Vx and your Vy. That's going to be V cosine of theta, V sine of theta. Okay, so everything about that previous thing works for this, except the only difference is you're going to be landing below. And by the same token, you can have this one. Look, I put a little castle in there just to make it nice. On this one, this is lands above. So it lands above the original, what did I call it before? Line, I guess. So there's where we normally would hit, but now we're hitting a dy value above. So when you do this, your dy value will be positive. If this is positive 17, that means it hits 17 meters above where it started from. Everything else, again, is completely the same. That's the range. This is the maximum height. There's no symmetry this time. So your time up does not equal your time down. You find your time up, and then this is going to be less time to get from there to there. And yeah, but everything else is the same. So we're going to do one type of question for each of these things. So you'll have an example of each. There you go.